Hello, I'm Prativarshan and I am here to present to you about Total Productive Maintenance, TPM proposal. Okay, this is for my assignment from University Technical Malaysia, UTM, and it was given to me by Sir Farid. And I am currently working and RSI automation with my industrial coach, Mr. Jason. So here, this is a presentation basically. So firstly, I would like to introduce you to TPM. So what is TPM? You might be having the question. So the definition of TPM is a maintenance strategy that aims to maximize equipment effectiveness through proactive and preventive maintenance activities involving all employees. So the key benefits of TPM. What are the key benefits? So the first benefit of TPM is reduces equipment breakdowns and it also improves productivity and increases workplace safety. Uh, Next is enhances product quality. And lastly, it involves all employees in maintenance. So basically, what is TPM is a maintenance that we do each week or each month that to make our product or our robots or our uh, basically our environment clean and safety for all the employees that work there. So that's it. We have actually TPM pillars framework. So there are 8 pillars which I categorize by two, where one and two are in one pillar, two, three, and four in one pillar. So let me explain that. So pillar one and two, the focus area for that is 5S, autonomous maintenance and Kaizen. So pillar one is 5S autonomous maintenance and pillar two is Kaizen. So if you get the idea, I can explain the next one is pillar three and four, predictive plant maintenance and training. So pillar five and six are training, education, and quality maintenance. So pillar seven and eight is office TPM and safety. So those are the pillars, and I would like to continue. So firstly, before we talk about the maintenance, I would love to talk about the company background that I'm working right now as intern, which is RSI Automation and Siliana Bahar. So the company profile of this company is a Malaysian industrial automotive company. That is the company type. So RSI Automation specialize in robotics integration, machine vision systems, and PLC programming. And RSI also focuses on Industry 4.0 solutions. So these are the core services in RSI automation. Firstly, we are going to talk about the surface area, and then I give you a description for that. The first surface area is robot system integration. So the description is automated production lines. So second is machine vision. The description for that is quality inspection system. The third is control panel, where the description is industrial automation hardware. Lastly is software and solution, where is smart factory technologies. So next, okay, this is the TPM implementation and overview. There are actually 5 steps of TPM implementation plan, which I will tell you about each step and the focus area TPM below. So the first step is 5S and autonomous maintenance. The activity that we do in here in RSI for this pillar is initial equipment clean and inspection. The second step is Kaizen. Okay. Activity that we do here is tackle root cause for further uh, maintenance. The third TPM pillar is predictive and planned maintenance. The activity there is schedule maintenance checks. Okay. The fourth step is safety and training. This is activity is employee development. Okay. So the fifth step is office TPM and quality. So the activity there is an administrative integration. Okay. So next, here I am going to talk about each step more in description, more descriptive. Okay. So the first step is initial equipment clean and inspection. Okay. This is for the pillar 5S and autonomous maintenance. So you have three questions in your mind. Might have a three question in your mind, which are who, what, and how. So basically, who are doing this uh, equipment clean and inspection? Basically, the operators. So operators are doing this equipment clean and inspection. Basically, either is every day or every month. So what are they doing is clean and inspect robots and conveyors. So basically robot in the industry is working on conveyors for better movement. So both of that needs to be checked and inspected. So how are they doing it? Basically with digital 5S checklist via QR code. So after they are done with the checklist, they actually send it via QR code to inspect basically. So the benefit of this implementation strategy is a real-time data collection. So everyone gets the collection in real time, easy access for operators, standardized inspection process, and immediate recording of findings. Okay, so that those are the benefit. Next, we are going to talk about step two, tackle root causes. Okay, this is for the pillar Kaizen and continuous improvement. So I'm going to point out with 1 point lesson OPL system. Okay, we have actually A4 sheet documentation for this tackle root cause. Okay, the component in the A4 sheet are photo, the root cause in itself, and the countermeasures. Okay, so first of all, the photo is actually for the visual evidence of the problem. So everyone knows what the problem is and what to do with the problem. So the next is the root cause is for identification of the underlying issue. So we have to identify what the issue is for us to give a solution. Okay. So the third one, as I said before, is the countermeasure, where we actually found a solution for the implementation to fix the issue. Okay, we actually have priority level for this tackle root cause, where it's categorized in three categories, which is high, medium, and low. So what that actually is when the issue is in high priority, we need immediate attention required. Okay, we need immediately get to the solution for that issue. When it's in a medium priority, we actually schedule when we can actually fix the issue. Which is scheduled for maybe like next week or 2 more days, something like that. So when the priority is low, we actually monitor first, monitor if the issue is getting uh, more problematic or not, and then we track it. So if the issue is somehow get into a point where it's more problematic, then we actually get into the fixing process. So that's it for step two. Next is step three, which is predictive and planned maintenance. From reactive to proactive maintenance. Basically, from reactive maintenance to proactive maintenance. So we actually have it in table here. which I actually describing as frequency. We have daily, weekly, monthly, and hour based. So the activity example for each one is daily is basic inspection, where operators actually check the robots and the robot arm daily. So every day we have to check them for it to move better and do not give any problems during production. So weekly is kind of more or less the same. It's a routine check where we actually check weekly for any other like problem that might occur in a week. Monthly is kind of the same, but it's in a monthly period where every month we have a comprehensive maintenance. So it's a more detailed maintenance for each robot. And our base is basically after a production creates an item, we actually check the robot if there's any like problems or anything like that. So it's actually a base joint J4 is J4 is a jig basically that product is being created. So we actually check the robot or the conveyors there. Um, Basically every hour or every like 2 or 3 hours, something like that. So next comes step four, which is safety and training. So training and education pillar implementation. Okay, so we have cross training programs where the task type is a basic robot reset, cleaning, and part replacement. Okay, description for each one is basic robot reset. We actually have a standard recovery procedure. Okay, so we actually recover the robot parts and all this. For the cleaning is a routine maintenance. So we actually routine it basically for like every like 5 hours. We actually do a routine maintenance cleaning. So a part replacement is a component swap where we actually swap the non-functioning component to a new one or a functioning one. So this one is our monthly preview process where we actually have our manager conducts a remote follow-up session. So every month, all the operators will come and do a meeting about what is there any problem with the robot or the conveyors, so all that. So the next is skill matrix review and updated. The lastly is training gaps identified and addresses. Okay. So next phase, the last and final step is TPM administrative and quality integration, where we have office TPM and quality maintenance. I listed in a flowchart for you. So we have quality maintenance connection. First, we have a robot gripper is misalignment. So a robot gripper actually misaligned with the robot. So what we do is scrap part quality defect. We actually find another uh, gripper online or basically find a new one basically, and we actually take a picture and send it to the operator. The next is maintenance action documented. So we actually document what happened with the gripper, all this into our Excel or A4 sheet, and then root cause analysis initiated. Basically, we document what the cause is of the gripper getting misaligned. We actually we analyze the problem and document it. Next, we have improvement of maintenance management documentation. So the current management documentation is not good, basically. So I would like to suggest some improvement of the maintenance management documentation. So we have digital VM documentation system. Okay, the problem that we are having for the traditional paper-based record, we have actually three issues. I will like to address them. The first issue is difficult data retrieval. The impact with this issue comes in wasted time searching for record. So operators have to search for the records for each record and then it take time for that. So the next one is delayed reporting. So since the data retrieval is difficult. So the decision making also will take a long time. So the last one is inconsistent record keeping. So the record keeping actually will be slower lah. It's not effective enough because slow decision making and the waiting time to for the record. So environmental maintenance history. So basically the history will be all over the place. So next, I would like to suggest two integrated modules for this implement maintenance. So there are two models of digital TPM system where one is a spare parts inventory. Okay, where I have three features here: stock quantities and minimum levels, which benefit prevent shortage. It will prevent the shortage of the components or the parts. Second is supplier details for quick recording. Okay. The last is automatic notification. So when a part is in low stock, we'll get alerted. So we know when we have to uh, restock basically. So the next one, work order management. This is the second one and the last one. So the component is fault description, priority and technician, repair action, and completion status. So the function for each one is for fault description is what's the problem? What's the problem for the fault? You have to actually document it. Priority and technician, the function is assignment tracking. So basically we can assign each operator for their task more effectively. So repair action, basically documentation of fixes. So all the fixes we do, we document it and keep it in a safe place for future reference. So the last one is completion status. We actually get to monitor progress of all the maintenance done by the operators. So next, so conclusion from all this maintenance is I actually have a summary and recommendation where the achievements are low cost TPM implementation, professional grade maintenance tracking, full coverage of all the 8 TPM pillars, and the lastly is integration of maintenance with quality management. So that is all for my presentation. Thank you for listening. I hope this helps with the maintenance problem. Thank you.